Start the pretest review. So eventually you will need a straight edge for the assessment. Number one, it's actually not necessary though. For number one, lines CE and AD intersect at B. Okay, so we have CE, AD. They intersect at B. What is the measure of angle CBA? So when we read our angle, we start at C, go to B, and to A. So this angle measurement right here is what we're looking for. These two angles are across from each other. It's a pair of angles created by two lines intersecting are vertical angles. Vertical angles are always equal. They're always congruent. Number three. Number three says, in which pair of figures can figure A be taken to figure B by a reflection? So figure A to figure B by a reflection. So which of these pairs is showing a reflection? Remember, with reflections, what was on the left is on the right, or what is up is now down. So the figure has an opposite type of look. Looks like it's a mirror image. So something like pair one would not be a reflection because these corresponding parts are in the same direction. So like this angle here matches this angle here. That's a translation. If your shape is going in the same direction for both, it was not reflected. With reflection, we're looking at like a mirror image. So if we look at pair two, so pair one is out. If we look at pair two, sharing a line like this is actually pretty telltale too. If you can imagine, see how this corner is on the left and this is to the right. This piece is to the left, this piece is to the right. That's a telltale sign that this would be a reflection. 3. It looks like it could be a reflection. The only thing is if it was, the line would be right here. And see how I have a corner or like a pointy edge here and a pointy edge down here? If this line was my reflective line, my pointy edges would be across the mirror from each other, and they're not. These would be across the mirror and they're not. If you tried to fold this up, so if you took your paper and folded it or you used a piecing tracing paper, you would realize that these do not line up. Pair 4, now I know we found an answer, but I just want to go through and eliminate the others just to be sure that I didn't make a mistake. So pair 4, same type of situation as 1. This is the exact same shape in the exact same direction. That means it's not a reflection. Pair 2 is our reflection. All right, number 5. Explain, so we have two parts with A and B. A says, explain why figure B is not the image of figure A after a rotation using center P. So it gives you all of the specifics. So I want to know why it's not the image after a rotation using center P. If you can't tell by just looking, you need to Trace it on tracing paper, line it up and see what happens. So what you'll find use my clear here. What you'll see when you try to rotate something strange is happening. Part of it lines up, but this piece doesn't. B is not the same size as A. And if you remember, when we rotate figures, the sizes don't change. So again, when we rotate a figure, the measurements don't change. B got bigger, or B is bigger than A. That's the problem. You have to decide how you're going to explain that and what you say. Okay. You can't, one thing you cannot say, so you can't say anything about I traced it and it didn't work. You can't say anything like that. You can't blame the tracing paper for this not being a rotation. You have to give a mathematical answer. Use math in your instructions or in your explanation. Even if you say figure B is not the same size as A, it's not the same figure. When you rotate, nothing like that should change. Okay? You can still give a simple answer, but you have to use math in your explanation. Same thing goes for B. B says, explain why figure B is the image of figure A after a reflection. Again, you can't say it's a reflection because the tracing paper worked. You can't say that. You need to give me some math. Okay, so when you look at this, and if you want to trace this, you can, there's nothing wrong with tracing it. And when you reflect, you can verify that yes, that does match up. Okay? It does match up when you reflect. If you didn't think about it like this, if you did not have tracing paper, how would you be able to prove and explain that this was a reflection? Okay, so a tip. If you didn't have tracing paper, how would you prove reflection with your words? Think about it like that. How would you prove this with words? Same thing with A. How would you prove that they're not it's not a rotation if you could only use words, no tracing paper? Okay. With the reflection, you can talk about things like each vertice is equal distances from the reflecting line. Okay, so however many units I have here, it's the same amount of units across. However many units are here, same amount of units there. Same thing here. Okay, it's a mirror image. You could explain using that vocabulary. Whatever vertice is to the left is now equal distance to the right. However many units that is. We don't know and it doesn't matter. But knowing that it's equal distance at each vertice could be something you could talk about in your explanation. Number 4, Here are three pairs of figures. So we have pair 1, pair 2, pair 3. A says, which transformation takes figure A to figure B in pair 1? So basically I'm deciding, is it a translation, rotation, or reflection that takes A to B? Well, hopefully you took your tracing paper, and what you'll find, and it'll be hard for you to see here, but when I take this shape, show you another way that you can check a reflection. So I'm going to cover this with pencil. So if I were to fold this down, try to reflect, now I can see it on my, you can kind of see it through. I use the edge of my pen and I kind of go over this. I get a little shadow. You probably can't see it, but I can. So when I reflected this, my new shape looked like that. Does that match up what I have here? A, B. Yep, that makes this a reflection. You can also see, because if my reflection line was right here, these points are equal distance away from the reflection line. Those points match up, those points match up. So I have corresponding sides here, corresponding sides, all across from each other. Okay, so for B, we'll do B in blue. So how does this shape become this shape? Well, you could draw it and you could test out each of these options, but we want to start looking at the characteristics and see if we can figure out what's happening. So if I look at my figure, do you see how they're going the exact same direction? Like this pointy side is upper left, this is upper left, this indent corner is on the toward the right, this indent corner is toward the right. All these corresponding vertices or angles are going in the same direction. That tells me it's a translation. And you could trace your shape and move it and see that they match up. In our last one, C, we're looking at pair number 3. Hopefully you can see that this does not look like a mirror image, so reflection is out. Translation, the two shapes look exactly the same. They're in the same direction and everything, just a different spot. These are in two different directions. Do you see how this indent is up and to the left? This indent is to the right. That's a telltale sign that we're not dealing with a reflection either. Again, I don't have tracing paper, but if I were to trace this, oops. So if I were to start here at A, I rotated, cut this out really quick so you could see. So if I started with A, I rotated, I could make it look like B. Now again, you would do that on your paper. I can see through this, but you can't. So you would use your tracing paper and you would see that that was a, oops, not a reflection, rotation. Right. 7A, draw the image of this figure under a 270-degree counterclockwise rotation using center P. Okay, so I have my degrees, my direction, and my center. Clean that up a little bit. All right, so first thing we'll do is draw my shape. Now there are no labels for the vertices, so that's okay. My center is P. Now because I'm given the degrees and I have grid paper here, I'm going to draw my little plus sign so that I can tell when I've gone 270 degrees. So counterclockwise is to the left, and every time my crosshairs or my plus sign lines up, it's been 90 degrees. So they line up here, that's 90 counterclockwise. That's 180 counterclockwise. You can see they're opposite from each other, which tells me we're doing the right thing. I'm going to go one more. Oops. One more. So that was 3 quarter turns. It was 1, 2, 3. And I end up with this shape right here. Now it's going to be very important that you're precise and you know where your points are going to go. Okay. So when you trace this, you're not going to want to be sloppy. You're going to want to be very precise, because if your points are all over the place, you're going to be marked wrong. Now, I know it can be kind of tricky to decide, like, how do you get, everything through? So what I'm doing, because my paper won't rip like your tracing paper would. So now I'm looking here, I have this point, so I'm going to go over 1 and up 2 for the next point. Over 1, up 2 for the next point. Line it back up. From this point, I'm going to go down 1 and over 2 for the next one. And my last point here is down 1, 2, over 1, 2. Just going to line everything back up. I'm using this little plus sign as my P as my lineup here. Okay, then you'll want to take your straight edge. So they were talking about having a straight edge. Sloppy is not acceptable. Use a straight edge so that you can get nice lines. Okay, that's number 7A. For 7B, 7B says, the figure on the left is reflected using line L. So this is line L. So that's our reflection line. Okay. So the figure on the left is reflected to form the image to the right. So this has been reflected here. Use the information in the original figure to label the corresponding parts in the image. So remember, with a reflection, if it was on the left, now it's on the right. So this point corresponds to this point. This point corresponds to this point. So if this angle is 82.9, that means this angle is 82.9. Same thing here. This far left vertex, the angle is 105.3. Draw along my line here. That means this angle is going to be 105.3 degrees. You've got to include that degree symbol. And I ran out of room in here to write my 105.3. This angle right here corresponds here. Now you don't have to draw these lines. I'm just showing you 63.4 degrees. Now there are some side lengths also. Okay, so this side right here, this side length is 6.3. The coordinating side length, so this is on the left side, it coordinates over here. So this would be 6.3. This is why it's important that you put the degree symbols, because that will help me see that you understand the difference between a unit measurement here for the length of the side compared to the measurement of the angle. And then we have this side over here, right here, corresponds to this side, and it's 8.5. That's it. For number 6, point A is located at coordinates 3, -2. Quick reminder about ordered pairs. Our first value is the x, second value is the y. This is the x-axis, y-axis. So when we plot this point, I start at the origin, 0, 0. 3 tells me I go to the right 3 on the x-axis. -2 says go down 2 on the y. So what are the coordinates of each point? So I start with A. Point B is the image of A after a rotation of 90 degrees counterclockwise, using 0, 0 as the center. So point B is the image of A after a rotation of 90 degrees counterclockwise. Okay. So, let's see, can we see this point? Okay. So I have A marked. We're going to put our little plus sign at the origin because that's our rotation point. And we're going to go 90 degrees counterclockwise. So I'm going to move to the left. And I know I've rotated 90 degrees because my little crosshairs at the origin line back up. Now mine kind of smudged. You'll be able to see on yours. So my rotated point is right up here. Now here's the thing, the directions ask for the coordinates. So you have a couple options for how you want to answer this on the paper. If you want to mark the graph, that's fine, but you need to label the coordinates. Start at the origin. My x coordinate is 2. My y coordinate is 3. So you could write your ordered pair here, or you could, we want to label it, or you could label it here. So either here or here, but somewhere I've got to see 2, 3. If you draw your point, make sure you label it. You could even just label this B and write your ordered pair over here. That's okay too. Okay, let's look at B. Point C. Point C is the image of A after a translation 6 units up, then a reflection using the y-axis. Okay. Is that okay? Okay. So translation 6 units up. 1, 2, 3, 4, 5, 6 units up. Now you can plot a temporary point if you need to. This is not your final answer, that's temporary. Then a reflection using the y-axis. Now, the y-axis is my reflection line. And what we know about reflections is my point will be equal distance from the reflection line. So if my point is 1, 2, 3 from the reflection line, I know my answer will be 1, 2, 3. So my reflection would actually be to the left. Original is 3 to the right, my reflection is 3 to the left. Now, if you actually wanted to fold along your reflection line, see how that matches up? So my answer is C. That was temporary. Get rid of that. So point C is at 1, 2, -3, up 4. Make sure you put parentheses around your ordered pairs. And then finally, point D is the image of A after a reflection using the x-axis, then a translation 3 units to the left. So the first thing is a reflection using the x-axis. Okay. So at my point A, my reflection is this x-axis line. So we reflect up, and what you'll see is my point. If this was my reflection line, A was 2 below, so my answer is 2 above, and actually that's point D. So, but I'm not done, right? Be careful. That's temporary. It's a temporary point. So I'm just going to plot it temporarily because then I have a translation 3 units to the left. So once I've reflected my point up here, here's my reflection point, I have to go 1, 2, 3 units to the left. So this is my final point. My ordered pair is, I don't go left or right at all, so x is 0, y is 2. So definitely label the points with your letter, and then you decide, do you want the ordered pair on the graph or the ordered pair over here? Up to you. Okay, so for number 2, select all sequences of transformations that could take figure A to figure B. So that could, select all. Okay, so there may be more than one answer here. So keep that in mind as you work. Okay. So you have a few options. We could go through and eliminate some of the choices here, uh, or just go one by one and see if each fit. Okay. I'm going to go one by one just so we can see which options could possibly work. So first is a single reflection. So that means one reflection only. One reflection has to make these pieces match perfectly. So let me get my little piece here. Now, hopefully, so that you can see this clearly, I'm using plastic instead of tracing paper, so hoping that this works well here. But a single reflection would mean that I can only have one reflective movement to match this up. That does not match. If I reflect straight to the right, it's not lining up perfectly. So there is no single reflection that will make figure A become figure B. A single rotation. So no matter where I put my pen, oops, no matter where I put my pen, it won't rotate. That's because if we look at the sizes of everything here, do you see how this here is the short side and this is the long side? When I rotate this, if I rotate 90 degrees, no matter where it's at, if I rotate 90, my shape definitely doesn't fit. But if I were to go more than 90, closer to maybe like 180 or something, the short side is on the bottom and the long side is on the top. And in my figure B, my short side is still on top. So a single rotation is not going to get me what I need, no matter where the center is at. So a single rotation is out. For a single translation, with a translation, my shape just slides, it moves. So if you see how this longest side is on the left, with my image, the long side would have to be on the left because I'm just sliding. Okay, so that would never match up either. So there are no single transformations that will get me from A to B. It has to be more than one. So let's see what options they give us here. Translation followed by a reflection. So can I slide this somewhere and to line up my shape so that I could reflect it to become B? Well, I could slide up and over. So if you see me slide up 1, 2, my top pieces meet or line up. Then I could so up 2 to the right, 1, 2, 3, 4. Now from here, now if I reflect, they match up. So D could work. Remember, we're selecting all that could work. So now let's look at E. A reflection followed by another reflection. Okay. So if I were to reflect to the right, I would then need to translate up. If I reflect to the right and then I try to reflect again, I'm not lining up. If I were to reflect diagonally and reflect again, it still doesn't line up. Maybe if I reflected this way, yeah, I'm starting to wear, my marker's going away here, but there are no options to reflect twice, as far as I can tell. Because even if I reflected like this way, so let me darken this a little bit here. So even if I was to reflect up here, if I reflected over, if you notice my long side is on top, my long side would be on top and my short side, yep, so that won't work either. The only option is D.